Hello, today we're on lesson 18b, so we're looking at linear versus nonlinear still, but this time we're looking at tables of values. And so today it says students will be able to determine if a given table represents a linear function and explain how the table represents or does not represent a linear function. So right here I'd like you to write in linear means constant rate, or in other words, an equal m. Nonlinear means not constant, not an equal m. So let's write that in and go ahead and highlight linear equals constant, not linear equals not constant, nonlinear equals not constant. All right, so we're going to be given tables of values. They're not always going to be in order, so what I have written here is put them in order, put in order. So I'm redrawing the table, and I'm going to redraw it according to the x's. So the smallest x that's here is -4. So I'm going to write that one first. -4 goes with 0. And then next up is -2. -2 goes with +2. Next up would be 0. 0 goes with 4. And the largest x here is +4 goes with 8. So the first thing you want to look for is as the x's are increasing, what's happening to the y's? So the y's are also all increasing. So that tells me that chances are this might be linear because at least they're all going up. If we draw it over here on the graph, we can see it. -4 goes with 0, -2 goes with 2, 0 goes with 4, 4 goes up here with 8. So it looks like it's pretty linear, but you never know. This sometimes might start curving down or might start curving up a little faster. So we check by finding the slope. So the change in y over change in x has to be found between all the points. So here it's adding 2 and adding 2, so it'd be 2 over 2 between those 2 points. But you have to see if it's going to be constant between all of them. So 2 over 2 equals 1. So we should see a constant rate of 1. 2 is added here, 2 is added here, so that would be 2 over 2, which is 1. So far so good, but we still need to check the last 2 points. From 4 to 8, they added 4, but from 0 to 4, they also added 4, so this would be a 4 over 4, which is still equal to 1. So we got the same slope between all of the points, so that tells me it's an equal m, so it's a constant rate. It's changing the same way the whole time. And so that tells me this will make a perfectly straight line. So this table represents a linear relationship. This one's linear because the slope was constant. So explain how you know it is linear. The slope is constant. The slope is constant. In other words, the same between all points. So unfortunately that means you do have to check all the points, but at least it's a pretty easy check. It's just change in y over change in x. So now let's write the equation of this line since we know it's linear. Y equals, the slope is 1x, so there's a 1 in front of that x, y equals 1x, and the y-intercept, the starting value is right here, is 4. So the equation for that line is y equals x plus 4. All right, let's check this next one. Again, the first step is going to be put them all in order. So I'm going to redraw this table right next to it. The smallest x value is -15, goes with -28. And then the next x value that's small is -3. -3 goes with -9. The next one would be 0 goes with -8. And 3 goes with -4. Now, if we want to, we can also graph. They did give us a graph here. -15, -28 isn't going to fit on this graph, but we can go to the next one. -3, -9 is way down here. 0, -8 is right here. And then 3, -4 is over here. So already I'm seeing that it does this. Okay, so that already is telling me that it might not be linear. It doesn't look like I can connect those with one straight line. But let's check with the numbers. So here the change in y from -28 up to -9, they had to have added, let's see, they added 19. And right here they had to have added 12. So this would be 19 over 12 as the slope between those 2 points. Between the next 2 points, it looks like they added 1, when over here they added 3, and so that would be 1 over 3. Already, I can see that these slopes are different. The slope is different between these points, which means this is a non-linear relationship. We only need to write the equation if we know the equation, and we can't see it here because it's nonlinear. So this is a nonlinear relationship. Explain how you know. Let's fill in nonlinear. Let's write the slope. The slope is not constant. And we can stop it there because if we can see the slope is not the same, then it's not linear. All right, the equation for this might be subtracting 8 from something, but we can't work that out with a nonlinear relationship, so let's not. All right, moving on to this one. All right, this one's a horizontal table. I'm going to rewrite it as a vertical one because I like vertical tables better. Let's look for the smallest x. Looks like it's negative 15. So negative 15 goes with 4. Cross out that one. Next one would be this one. 0 goes with negative 3. Next one is 5. 5 goes with negative 4. And 10 goes with negative 6. So at least I do see that it's all decreasing. It doesn't like start decreasing and then increase. So at least there's that. Let's go ahead and now check the slope. From 4 to negative 3, it went down 7. From negative 15 to 0, it went up 15. And so that means that slope between those 2 points would be negative 7 over 15. Let's check the next two. From negative 3 to negative 4, it went down 1. From 0 to 5, it added 5. So that would be negative 1 over 5. So that already is telling me that this is not constant. So we don't have to check them all if we notice the first two are not constant. All right, so if it's not constant, it is non-linear. All right, let's check the next one. Rearranging the x's isn't necessary because this one's already in order, negative 3, 0, 3, 12. And so let's look at what's happening with the y's. Negative 12, negative 9, negative 6, positive 3. It does look like they're all increasing. So let's check and see if it's a positive or negative relationship. Let's see what's going on here. So the change in y from negative 12 to negative 9 is adding 3. From negative 3 to 0 is also adding 3. So change in y over change in x would be 3 over 3, which is 1. All right, let's check this one. From negative 9 to negative 6, they added 3. From 0 to 3, they added 3. That again would be 3 over 3, which is 1. Okay, so far so good. They're constant so far. Checking the last ones. From negative 6 all the way up to 3, they added 9. From 3 up to 12, they added 9. So that would be 9 over 9, which again is 1. So since we were getting the same slope every single time, 1 and 1 and 1, that means this one is a linear relationship. Since it's linear, let's write it out. Y would equal 1x, and then it looks like their starting value right there, where x was 0, y was negative 9. So there's our equation. Y equals 1x minus 9. All right, determine if the table represents a linear or nonlinear relationship. If it's linear, determine the rate of change. All right, so let's go ahead and look at these. I see they're not all in order, so let's change up this one. Let's see if the y's are doing the same thing every time. So the first one would be 0, negative 3, and then 4 would be next. 4 goes with 0. 12 would be next. 12 goes with 6, and 16 goes with 9. So let's check. All the y's look like they're increasing, so there's a chance that this might be linear. Let's see. It looks like here it added 3. Right here it added 4, and so that would be 3 over 4. All right, here they added 6, where here they added 8. So that would be 6 over 8, but 6 over 8 reduces down. Sorry if that's too small for you to read. Let's zoom in. 6 over 8 reduces down to, let's see, divide by 2, so we have 3 over 4 again. All right, and then this last one, from 6 to 9, they added 3. From 12 to 16, they added 4, so that would be another 3 over 4, and I can't reduce. So it looks like between all of these points, the slope is 3 over 4, 3 over 4, 3 over 4. And so this one would be linear. Linear. The slope is 3 over 4. That's all they're asking for here. All right, let's look at this one. Looks like the x's are already in order. What's happening with the y's? Looks like they're all decreasing. All right, so let's see how much they're decreasing by. From 9 to -6, they took away 15. From 0 to 15, they added 15. So that little slope would be -15 over 15, which is -1. From -6 to -16, they took away 10. From 15 to 25, they added 10. And so that would be -10 over 10, which is -1 again. All right, let's check the last one. From -16 to -23, they took away 7. From 25 to 30, they added 5. So that one would be -7 over 5. Which is not equal to the others. And so just with this little part here, that makes this non-linear, because even one that doesn't match with the others makes it not constant. So that one would be non-linear. All right, let's look over here at this one. I'm going to rewrite the table because it's not in order. It goes 0. Oh, 0 is not the smallest x. -4 is the smallest x. -4 goes with -1. Then 0 goes with -3. Then 6 goes with -6. Then 10 goes with -8. So already I'm seeing all the y's are decreasing. So there's a chance. Let's see if it's linear. From there to there, it's subtracting 2. From -4 to 0, they added 4. So that would be -2 over 4, which reduces to -1/2. All right, let's check the next one. From -3 to -6, they subtracted 3. From 0 to 6, they added 6. So that would be -3 over 6, which also reduces to -1/2. So far, so good. Let's check the rest. From -6 to -8, they subtracted 2. From 6 to 10, they added 4. And so that would be -2 over 4, which means this reduces to -1/2. So was the slope constant? Yes, this is linear. Linear, and the slope is -1/2. All right, last one. Here we go. It looks like the x's are pretty much in order. Oh, looks like there's an extra one there. So let's rewrite these in order. X and y. 0 and -6. So let's see. -6, the smallest, goes with -10. 0 would be next, goes with -2. 15 would be next, goes with 18. And 18 goes with 22. All right, so already I am seeing that the y's are all increasing. And so that tells me there's a chance that this might be a line. Let's see. From -10 to -2, they added 8. From -6 to 0, they added 6. So that would be 8 over 6, which reduces to 4 over 3. Let's try the next one. From -2 to 18, they added 20. From 0 to 15, they added 15. That would be 20 over 15, which reduces again to 4 over 3. Let's try the last one. From 18 to 22, they added 4. From 15 to 18, they added 3. So that one would already be 4 over 3. And since we got 4 over 3 every time, that means this is linear. And the slope is 4 over 3. All right, so that is it today. So that is checking slope, checking the rate to see if it's linear or nonlinear. Don't mind that bell. Do your exit ticket and ask me if you have questions. Have a great day.